Today I'm looking at an IBM pSeries POWER6 server from 2007, saved from a dumpster in Kansas. We'll take a look around the thing, pull some cards out, get a deep dive of the history of these power machines, including their relation to the IBM AS400 line and the IBM I operating system. Finally, we'll power the thing on and see if it works, take a look at something called the ASMI, its remote management system, and I have a pile of this IBM gear in what I'm calling the retro rack, including something called an HMC, or Hardware Management Console. This is a server which gets networked up with the internal remote management computers inside these IBM enterprise servers, and it lets you remotely manage many of them over a very mid-2000s Java-backed web interface. Let's get into it. This is an IBM pSeries Enterprise Server. It's got a POWER6 CPU inside. It was released in 2007. I think this thing was built in 2008. And it's what IBM called a P520 Express entry-level enterprise server. Its exact machine type and model, IBM like to have a bunch of names for everything, machine type 8203, model E4A. This machine could come in a variety of configurations from IBM, and I've been kind of looking at the hardware and assessing it, and I'm pretty sure we have the lowest end model here, a POWER6 CPU running at 4.2 gigahertz, which is pretty impressive, but it's just a single core, and it would have set you back $5,576 retail in 2008, or about $8,500 adjusted for inflation here in 2025. And you can see it's missing a few components. The front bezel is missing, which is a shame because the aesthetics are half the fun with this IBM P gear. And I don't have the lid over here. I've got some theories, but this thing was in a dumpster for sure. It got saved from a dumpster, I'll tell you that story. And I have a couple theories as to why these things might be missing. But first I want to go over what makes these things special and unique, at least in terms of enterprise servers in the mid-2000s. Down in there is what's called the POWER6 CPU, and it is a RISC-based architecture, reduced instruction set, meaning it is different from something like this Pentium 3 x86 architecture. Now, I'm not an assembly or CPU expert, but basically a CPU performs these things called instructions, the CPU actually doing something like storing a number or adding a number to another one. And basically with RISC, the CPU does less actions for each instruction as opposed to something like x86. So if you're adding two numbers, for example, I'm sort of paraphrasing this, but it might take 4 lines of assembly and maybe 3 to do it on this one. But behind the scenes, theoretically at least for RISC, the 4 instructions are faster because they're doing less than it takes this thing to do 3 because it's doing more work behind the scenes and making it easier to program. That's the idea, the high level idea. Anyway, basically you're not going to be installing Windows Server on this thing, is what I'm saying. So the history of this particular unit and how it came into my possession. This came in a huge lot of stuff I bought from Winman 486 about a year ago, including an RS6000 server, which is the predecessor to this POWER6 machine. We'll go over that. The story goes, it was in a dumpster, which might explain why the bezel and the lid are gone. Because, you know, maybe someone threw it in the dumpster, and those two pieces could easily just kind of fly off. The bezel, for sure, it might have just cracked into a million pieces, and also, if the lid was not screwed in with its captive screws, it would have gone flying as well, potentially. This and that RS6000, so they must have been an IBM shop, belonged to an ag co-op, an agricultural co-op in Kansas, the state of Kansas here in the United States. And it was being used to run databases, ag databases, along with that RS6000, all the way up until the early 2020s, I think. Now, an alternative theory to these missing pieces is you could also get something called a desk side kit, which allowed you to turn this thing up on its side and treat it as a tower, you know, a tower PC type form factor, and put it under a desk. I think they had like noise dampening because, as we'll see, not the quietest thing in the world. And they had a special vertical bezel that would allow you to set it up on its end and use it as a desk side kit. That's kind of my best theory, because otherwise I was saying the lid could leave, but that seems sort of unlikely. The bezel being gone doesn't surprise me. So I think potentially this was a desk side kit. And a little more evidence, there's usually these pull handles that pull up right here on the side, at least one, and they're missing on this unit on both sides. And I'm guessing you would have taken those off to install the desk side kit. It's a shame I don't have the desk side kit. They're very hard to find, and when you do on eBay, they're hundreds and hundreds of dollars. There's exactly one out there right now for this, and it's not even complete. It doesn't have the side panels, which of course would be desirable in my situation. As you'll recall, I was saying IBM calls this a 520 Express, which can be pretty confusing. The POWER6 CPU in here came out in '07, that's when this was released, but I already have a 520 Express. It's a P5 520 Express, and it's a totally different machine running the Power5 CPU. So that's pretty confusing. It's actually hard to tell at first glance when you're talking about the 520 naming convention what's going on here. And that's because IBM was going under a massive rebrand right around the time this came out, and it's very confusing, and I'd like to explain it to you. In 2008, this machine and all other P-Series machines were pulled under what IBM calls their Power Systems line, and it remains that way to this day. In fact, in July of this year, 2025, IBM announced their new Power 11 processors and machines in the Power line. But Power Systems is actually the convergence of two prior enterprise server offerings, the System P and System I lines, each of which have their own interesting history. Let's start with System P. The predecessor to the POWER6 machine on the bench today is the RS6000 line, released in 1990. The RS6000, or RISC System 6000, were a series of enterprise workstations and servers which used the PowerPC and Power processors. The Power processors continued to be iterated on and eventually ended up in the System P machines, which came later. Starting with the year 2000 and leading up to the 2008 Power Systems rebrand, a rather confusing series of marketing rebrands took place. From 2000 to '04, they were called the eServer P-Series. From 2004 to 2005, the eServer P5. From 2005 to 2007, System P5. And finally, 2007 to 2008, System P. Best I can tell, the System P thing was short-lived and came around with the introduction of the POWER6 CPU. These dates are approximate, it's a little tricky to nail things down, and to make things even more confusing, the eServer branding was used all over the place, from these Power machines to x86 servers as well. In fact, you could do a whole video about the eServer branding. It was itself an umbrella, much like Power Systems became, for a whole bunch of different IBM server and storage products. When the eServer branding was retired, the lines under its umbrella were in turn rebranded themselves. Throughout the lifespan of System P in all its marketing iterations, their intention was to be used as Unix workstations, typically running IBM's own Unix variant AIX and later Linux to compete with the likes of HP, Sun, and others. But that is the rough timeline overview of the P-Series, from the RS6000 introduction in 1990 all the way to the Power Systems consolidation in 2008. Luckily for us, they haven't rebranded since then, so Power Systems has had 17 years of staying power so far. But as I mentioned, the Power Systems line was a convergence of both System P, which we just covered, and something called System I. To round the history out, now we'll take a look at System I. We'll have to go all the way back to at least 1988. Now, it can definitely be argued that System I technically began its life far before 1988, but we'll start at the venerable AS400, or Application System 400, line of computers. They ran a really interesting operating system called OS400, or Operating System 400, which eventually became known by its current name, IBM I. IBM I is a very interesting beast, built to allow application developers to write software which was agnostic of its underlying hardware and CPU architecture, using something called the Technology Independent Machine Interface, or TIMI. This is one factor that allowed the two lines to converge around the Power architecture, in fact. For example, the AS400 originally used a CISC-based CPU, a totally different architecture from PowerPC. Because of the TIMI layer, software that was written for AS400 was able to be ran on PowerPC and Power 4 and 5 and 6 processors, allowing for hardware conversions with the P-Series. I haven't used IBM I, or OS400, the operating system for these AS400 machines, but I gather that it is a fair starting point to get an idea about how IBM I became what it is today. Technically speaking, though, it was a successor to older systems, the IBM System 36 and IBM System 38, each of which, of course, succeeded machines themselves, so it has a very long history. Now, I don't actually have any gear that can run IBM I, so we'll cut this history a little short, though technically, the POWER6 machine on the bench could run it if the licensing was correct. I highly suspect I don't have a license on there to do so. But suffice it to say, between 1988 and 2008, the IBM I went through all the marketing and renaming funny business that the P-Series went through as well. And with that, we have finally come to how IBM Power Systems came into existence in 2008. Not a perfect history, but hopefully it gave you an idea of how we got here. I wanted to put it in financial perspective. You know, how many of these things was IBM selling? Was this a going concern? How much money were the P and I series making? Here in the US at least, a public company needs to file a Form 10K at the end of every year with the United States Securities and Exchange Commission. Basically, they go over where they made their money, where they lost their money. They like to put in like competitive threats, where they think they're winning, stuff like that. Well, let's look at this 10K from IBM from 2004, kind of right in the heart of all that pSeries stuff I was telling you about. And if we have a look, they've grouped the pSeries and iSeries and Z and X, so that's some mainframe stuff and some like x86, you know, server hardware, all into one thing called Systems Group. And for the year end 2003, this report was filed in 2004, so it's for the previous year, sorry, 14,000, but that's in millions. So this is a $14 billion business, and at least for the P-Series, IBM claims it's growing 12% year over year as of the beginning of 2004. It's not the fairest comparison, but just to make things as consistent as I can across all the 10Ks we'll look at, in 03, they had a hardware revenue of 28 billion. Here's a 10K filed for the year of 2007, so this represents how 2007 went for IBM. And you can see they've renamed. It's not P-Series anymore, it's System P, just like I was trying to explain. And they've lumped up everything a little differently into this systems and technology revenue, but they're claiming 21 billion is how they did with this stuff. Now again, I'm going to flip back and forth. You see, there's different stuff in these lists, but they're more or less the same. The printing systems business was down way bad year over year in 2007. But I think overall, at least the way IBM likes to report the hardware revenue, it's declining. One interesting thing to note is that System I was down 10% year over year in 07, and System P was up 8.8%. I believe this is just before the consolidation, so I'm not sure if that's related. Just for fun, let's look at the 10K from 2024. I am not good at reading these. This is not financial advice. I'm just trying to get a feel for how the business is doing, I guess, because I really like these machines and it's interesting to see how they're doing. It's a little trickier to read this one. They don't call out IBM Power Systems specifically, as far as I can tell. I think they're lumping it under this hybrid infrastructure. They do call out IBM Z, specifically the mainframe stuff. 99% sure hybrid infrastructure is where all the power system stuff is being accounted for. Correct me if I'm wrong, but it's fun to look at anyway. So for all of their infrastructure, this includes the mainframes, 2024 was 14 billion. And again, back in the 2003 filing, all of the hardware revenue was 28 billion. So from 03 to basically last year, they've gone from 28 to 14 billion. Again, this isn't quite a fair comparison because this has the personal computers division in here in 03. They don't even have that anymore. They probably were playing some games around whatever technology group is and engineering services. I don't know if that's lumped into the new one, but I think it's safe to say hardware revenue is down over the 2000s. But it's just interesting to look at. I wouldn't go out and make any decisions on this information I've just showed you. Not a very scientific analysis, but that's enough of this. Let's get back to the machine. The plan is we're going to fire this thing up and see if we can't get it doing something. Now, full disclosure, I have turned it on before. I was down here messing with it and I got kind of excited and wasn't filming it. And yeah, it powers on. It appears to be relatively healthy. Let's get to know it a little better, have a little walk around, and we'll pull some of this crap off and take a closer look at the main board. On the front, we've got two redundant power supplies. They actually just took the IAC connectors from the back and they route them through the case and they plug in just like that. So I suppose you could just plug it in right there if you really wanted to. These are removable, of course, so you pull the plug, you pull in these little tabs. The orange means they can be pulled while the machine's running, at least one of them anyway. There's a button right here. You get that with your thumb. There's a handle. It's actually quite nice, and they aren't all that large. Of course, they slide right back in. That's nice and easy. Over here, we've got what's called the operator's panel. This is really important for these P5 machines. As the machine is booting up, it'll display progress indicators to let you know how far it got, and you can Google those to figure out, when it gets stuck, where is it at. You can do a little bit of interaction with it, which we won't need to do, I don't think. So that's very useful. We'll be looking at that later. It doesn't clip in. I think maybe the bezel was required for it to clip and then you would have released it that way, but it's always just kind of loose. We've got an expansion slot for like a tape drive or another CD-ROM or DVD-ROM, I guess in this era. I believe this would have been like a slim DVD-ROM right here. It's missing, unfortunately. And then we've got the drive bay. 6 SAS drives, which is pretty nice. And this is pretty spicy. There's a hard drive in one of these. Branded IBM eServer, pSeries, now you know what all that means, so that's early 2000s. It is exceedingly rare to get a hard drive with enterprise equipment that you pick up because they almost always pull them and wipe them and recycle them or just destroy them entirely for data privacy reasons. And these are SAS drives. We're in the modern era here. The older P5 machines I have 2 of them, use these godforsaken drive caddy trays with this converter board on the back from SCSI 3 to this IBM proprietary edge connector. And so you basically have to have these to get a hard drive in the thing, which is really annoying, let me tell you. So this is really nice. You can just pop a SAS drive in that bad boy. That's fantastic. Looks like this one is a eServer pSeries branded IBM drive. I don't think IBM made this, of course. It would have been manufactured for them. It is a 146.8 gigabyte, 15,000 RPM SAS drive. And I know what's on here, because again, I got excited one night and booted this thing up a couple days ago, but I'm going to leave that as a secret for later, and you can find out later in the video. Around back, here are the power connectors that just snake through this thing with those cables I was showing you. Some USB ports, bunch of blank slots, PCI slots, and then a network card with 4 interfaces, and wow, I am just noticing they're really nice. This is a 1 gig and 10 gig card. What did an agricultural co-op in Kansas need with 10 gig Ethernet? That's pretty wild. It's labeled really confusing. I don't actually quite understand it. On the 1 gig side, it's labeled T1, T1 twice, and then T1 once over here, T3, T4, and then T2 again over here. That's weird. Maybe you bond them together or something to get the full 10 gig. I'm not sure what's going on there. That's interesting. Down here is the remote management interface. You can see it's labeled HMC 1 and 2. That stands for Hardware Management Console. You can optionally use something called a Hardware Management Console, which is literally another server. These days they run them in VMs, but I've got a physical hardware HMC that we're going to try to get plugged into this thing. It's basically running like a slimmed down Linux version with a bunch of IBM's Java code running on it that lets you remotely manage these machines. My other Power 5 machines are under remote management on the HMC, and I think it's running software that will accept this POWER6, so we'll try that later. To the left, we've got 2 serial ports. S1 will be our initial interaction with the machine over a serial console. And then I had to look up what these are. SPCN1 and 2 stands for System Power Control Network, and based on some really light reading, that seems like some IBMI stuff. Again, this machine is theoretically capable of running IBMI from a hardware perspective, but it had to have the correct licenses put on it when you ordered it. So I don't know if it has those. And then this little connector right here is a SAS connector. So for connecting to something like a disk shelf for more storage. Moving on, let's have a closer look at some of this stuff, and then we'll finally power it up. So we've got these 4 fans. These are, I believe, the only fans on the machine outside of the power supplies. So they're sucking air through the machine and out across the CPU and the RAM, and so this baffle is quite important. In fact, it would be pretty sketchy probably to run this without this baffle for any given period of time, since I don't have the lid, which also helps with airflow. The CPU fans suck air across themselves and then cool off the PCI cards here in the back. So these pull out, these little turbine style deals there. And then let's see, they are red, meaning you can replace them during operation. These blue things mean only pull this stuff out when the machine is off. There's these little pull pins that aren't too bad. This thing is a little finicky to get out and even harder to get back in. So there, this whole baffle removes. Then down in here, we've got the POWER6 processor and 2 sticks of probably DDR2 RAM. I don't know why I kept saying this is red. This is obviously the color orange. Not going to pull the CPU. We'll inspect it with the remote management software and maybe even an operating system to see what it really is. Let's pull a RAM stick. 1 gig sticks of PC2 5300P ECC, error correcting code RAM, so server RAM. Let me go look at my stash just for fun and see if we could upgrade this thing from 2 to something else. That base model with the single core processor came with 2 gigs of RAM. Not definitive proof, but that's another thing making me think this thing is the lower end model. I think I found what we need. So I've got 4 2 gig DDR2 ECC sticks. One of them is even IBM branded with the IBM FRU on there. I was reading that even in the single core configuration, it can use up to 16 gigs of RAM. So let's get it up to 8. I think that's the most I have in the configuration that'll work for this. The RAM that was already in here appeared to work fine. So if this new stuff doesn't work, we'll just swap it back in, I think. This gets me every time. This is not compatible. So they're both DDR2, but you can see the notch is slightly different. There are so many variations of DDR2. Let me go look again. I found one with the right size, but it's a different speed. So much for that. Back to 2 gigs. And then down in here is a very suspicious looking module. That looks like the type of thing IBM would put in a machine, and the machine won't work without it. So I'm curious to see what this is about. Apparently this is a VPD card, or Vital Product Data Card. It stores information about the machine and I think what it's allowed to do. So how many processor cores it's allowed to have. And this exact one is on eBay for $500. So I'm gonna put that back and never touch it again. And way down in there is a system battery, which I believe is dead. This thing couldn't store time between reboots last time I was messing with it. So I'm gonna replace that, and I'm gonna do something everyone hates. I'm gonna use some metal pliers to do it, because I don't have any plastic ones. There we go. It's one of those kind of like double height deals. What is this thing? CR2450N. I think the N is what makes it kind of funny. And I'm guessing it's totally dead. Yeah, 200 millivolts. Totally dead. And I know, you should not, short electrical components, but it is a dead clock battery. So I think it's okay. Got the new battery in there. Side note, the only one I could find as a replacement was by the same brand, Renata. And of course, I'm being a little fast and loose and kind of making a joke about these. I firmly believe using these on a dead battery isn't going to cause a problem, but if this was like a rare machine, an older one, I would obviously be a little more careful. Do what you got to do with your stuff. 2 more interesting cards I wanted to have a look at and inspect online. This weird one right here. And that Ethernet card with the 4 ports is something called an IVE daughter card. I don't know what IVE stands for yet. But let's get this one out. It's got like a little, let's see here, little pull handle. What is this? This might be the service processor, the thing doing HMC. Let's find out. This is apparently a thermal management card, or TPMD, I guess the documentation calls it. I don't see any sensors on it, so it must be in control of somehow measuring and maybe doing something about temperatures inside the machine. I've never seen a card this big dedicated to that. That's kind of cool. And then down in here, this IVE daughter board networking card. Usually it's toolless. I think we do that. Yeah, interesting. Okay, this one's really cool. IVE stands for Integrated Virtual Ethernet, and it's basically allowing network hardware closer to the rest of the machine hardware, and these things can be divided up into what are called LPARs, or logical partitions. You can think of them as VMs. And basically, I can virtually pass a port on this card to a VM in this IBM Power environment. So yeah, we're gonna have to play with that in the future. That's exciting. Yeah, I was taking a closer look at the documentation, and on the right is with this IVE, Integrated Virtual Ethernet. The writing on the back makes a little more sense. You can have 2 ports running at 1 gig, 4 ports running at 1 gig, or 2 ports running at 10 gig, apparently. Those are the different modes. And on the left is how you would traditionally expose Ethernet network adapters to LPARs. The boxes here with AIX and Linux represent a VM, essentially. I've never done virtual IO server, but I will in the future someday. If I have gear that can support it, I believe I do. Long story short, you can just see the path to the Ethernet adapter is shorter. There's less stuff going on. So theoretically, I guess, better throughput. At any rate, I'll have to explore this in the future for sure. One last thing before I throw this baffle back on. This is the back of the machine you're looking at. The air blows out, and these little flaps only let air blow out, so that when you are pulling a fan, or one fan's out or down, it doesn't allow air to suck back in and kind of fight against the system. It'll only allow air out, which is kind of cool. Don't know how necessary it was, but pretty neat nonetheless. Let's get these fans back in here. Funny note about this thing. I had it sitting a little proud the last time I attempted to power this on, and it kind of gave me some headaches. So you put the fans in and they clip, and they can do that. And if this thing is still up a little bit, they aren't actually making contact into their connector. And what happened is I tried to launch the machine, fire it up. Didn't make any noise. I was looking at the progress indicators on that op panel I was showing you earlier, and I deciphered those, and basically it tried to start up and then stopped because of a critical fan error, 4 critical fan errors. I'll show you those errors later. And I was able to deduce that my fans weren't plugged in, so I'm going to try to press this in pretty good here. Okay, the first thing we're going to do is get it connected over the serial port. I've got it plugged in here, but no power is being given to it. And we're going to flip the power, and the machine won't start up. What's going to happen is we'll be able to barely hear the power supply fans running, and something called the flexible service processor will power up, or FSP. If you remember those HMC ports on the back where we connect up a hardware management console, well, inside the machine is another computer, basically, called the FSP. And it's basically the remote management of this thing. And we'll be able to interact with it over the serial console and a web page. So what I'm going to do is we're going to turn this thing on, and then we'll go look at the operator panel. Power supply fans are up. And on the operators panel, we can see some progress codes. That tells us where in its little boot process it is. Eventually, that'll stay steady, and we'll be able to interact with it over the serial console. Over here on the serial connection to that machine, you're supposed to press enter, and we're not getting anything yet. That means the service processor I was talking about just hasn't finished booting, so we'll give it a few more moments. The progress codes are done, and we're left with this. This screen means it's ready to be interacted with, the service processor. We'll go over these cryptic letters later. Back here, should be able to press enter, and there we go. I believe the default user is admin, default password is admin, and in my case, I was lucky. It had just been set to defaults. So here we are. I don't know what this menu's called, actually. It is, of course, the ASMI serial console. ASMI stands for Advanced System Management Interface. There is a web version, which we will look at shortly. Here's the serial version. Let's see here. What do we want to do? Let's look at system information. You click a number to traverse the menu and press enter. Let's look at vital product data and see what kind of processor we have, maybe. Oh boy. Next page. There it is, processor. Doesn't tell us much. It is this thing. I'm going to look that up. Looked it up, single core POWER6, as we feared, so the lowest end model. Something funny is you can see the system name is 98. I thought that was kind of odd the first time I was in here. But if you go into system configuration and you type system name, now remember, you type the number of the menu item you want, but there's always this 98 to go back. So I can do 98 to go back into 4 for system configuration. And if I go to system name, it just forces you to type a new value. It doesn't prompt you if you're ready or whatever. And so clearly someone went and panicked and said, oh, I need to go back. And they set the system name to 98, which I think is funny. So let's do system name. Let's call this POWER6 1, in case I ever get another one, I guess. Time of day, it's invalid and needs to be set. That's no surprise because I changed the battery. We'll do that in the web interface. Speaking of the web interface, let's go into network services, and we can go network configuration, IPv4. Let's look at ETH0. This is going to be the HMC number 1 interface. So it's at 169.2542.147. Let's go look at the other one. And the other one is at 169.254.3.147. I'm going to want to remember the address of Ethernet 0. These are the default addresses, by the way, for a HMC1 and HMC2. So this thing was either never configured to be different addresses, probably never had an HMC, or has been factory reset for some reason, which is convenient for me. Well, let's go see if we can see this on the web browser. The serial console's all well and good and fun, but let me show you the good stuff. We're going to connect this up to HMC1. We're going to make a little network here for ourselves with a laptop. Get the laptop on the other end. And let me show you some 2008 era remote web management action. We're going to need the trusty IBM ThinkPad T60. Get this guy booting up into Windows 7. And then we'll, of course, plug it into our little HMC network. I guess it's, as you'll see later, it's not really an HMC at this point. We're going to be accessing ASMI, Advanced System Management Interface, basically a web GUI on top of that serial console UI I was showing you. So you can see there, I've got this laptop on the same network, different IP obviously, as that HMC port 1. And if we hit that IP of that first port in the browser, i.e. 8 over HTTPS, it's going to complain a little bit. Well, give me a minute. It is hard to get it to connect when it doesn't think it's on the internet. Just do it. Oh, it also helps when I put the IP in correctly. Maybe. We're close. We can ping the ASMI. I just can't get the browser to load it. I'll be back. I don't know why, but it started working for no reason. So I think that was more IE's fault. We're going to continue. Oh yeah, IBM Advanced System Management. So it's the same user pass, at least in my case. Admin. Let's get logged in here. To be fair, it says it supports IE7 and I'm using IE8. I don't know. Who knows? And look at that. It knows we are logged in right here, and it knows my other admin session is over the terminal. That's pretty cool. And you can do all sorts of stuff in here, like power on the machine. Let's go look at, I'm just trying to show you the fan errors I got before. Yeah, let's look at the error event logs. Oh, I deleted them. Never mind. We can set the time and date though. That could be cool. It is August 3rd, 2025. Let's see if that persists next time we restart that. That'll be nice. So in system information, we can go to real-time progress indicator. And this is my favorite part. It is a HTML web-based representation of the operators panel. Gotta love that. And we're gonna put that over here for later. And we're gonna power this thing on, and we are going to tell it to boot to something called the SMS menu, sort of like a BIOS for these things, one could argue. We are gonna save settings and power on, and it's gonna get real loud in here. Well, not immediately. These are the progress indicator codes happening live on the panel. There we go. It's pretty loud. I love these things. So we're seeing the progress indicator codes spitting out over the serial console as well. Gotta love it. It actually kind of revved down, which is nice. It was real loud when it first ripped up. And here we are. I don't think it even took about 5 minutes. It does an extensive amount of checks as it starts up to decide if it's healthy for itself to continue running. I think we want to do continue boot. I'm going to accept the license code. And here we go. It's got a speaker on it. It just beeped at me. Let's do 1 for SMS menu. Continue to password entry. And the admin password, as we know, is admin. So here is SMS. System management services. You can set the boot options, stuff like that. You can set up remote initial program load, boot this thing over the network. Maybe we'll do that someday. Let's go into boot options, select the boot device, and I'm just going to list all devices. That's usually the right way. It's going to go off and scan everything it can find. So of course we have these Ethernet adapters we could boot off over the network, and there is our 136 gig SAS hard drive. So I'm going to boot to that. Normal boot mode, and this is going to exit SMS and boot to whatever's on that hard drive. Get ready. AIX. I'm pretty sure this is a fresh, brand new install of AIX 7.1, which is the Unix variant from IBM that definitely would have been running on these pSeries machines for sure, vast majority of the time. Sees all our RAM. Yeah, I'm just like in shock. Now, I knew this AIX was on here. I've booted into it exactly once. I think it's a fresh copy because it doesn't have a root password. But let's get in there and root around. Maybe there's some stuff installed. So we boot it up, and I'm going to do root, and there's no password. So, yeah. Here are the console messages coming through complaining that one of the power supplies is not plugged in, which is fine. We're cool with that. I don't even know where to begin. How do I see if stuff is installed? Yeah, I'm pretty sure it's fresh. I don't see any suspicious software running, no cool agricultural databases or anything like that. And there's no additional users other than the defaults. So pretty weird though. Winman46, who I picked this up from, doesn't recall ever installing AIX. So it must have been that way when he picked it up from the guy that pulled it out of the dumpster for him. But that means, against all odds, giving its dumpster origin, this thing is healthy, and it already has a copy of AIX installed, which is probably what I would have done anyway. So what we're going to do here is power off the machine remotely from our ASMI here. And it's complaining that we have an active AIX partition. That's fine. And in fact, over on the AIX terminal I'm logged into, you can see it's been told to shut itself down. So it's cleaning itself up. It's quite the integrated ecosystem. Okay, it is shut down. Just the power supply is running. So of course I can still access the ASMI. It takes a few minutes for these things to shut down. So don't be alarmed if you've told it to halt, and it takes a while. I'm kind of still, I mean, I already knew it because I'd played with it earlier, but I'm still sort of in shock that this thing just works. So the next thing we're going to do is get this bad boy hooked up to my HMC. In the other room, I've got a rack I'm calling the retro rack, and at the bottom, that's where my other pSeries machines are that I want this one to join. The actual server acting as the physical HMC server is in there as well, and on top you can see there's an IBM hub. The HMC network is a 192.168.1 network, and it's totally isolated to just this hub. Those two other servers in there also have these HMC ports, and they have cords going into the hub you were just looking at. So what we're going to do is configure this second HMC port to be on that 192.168.1 network, and then I'll be able to plug this thing into the hub over there and hopefully take ownership of it with the HMC server. And in fact, I'm actually going to put the HMC server on top of this one to act as a lid of sorts for airflow reasons. So I'll bring that stuff in here actually and show it to you, the hub and the HMC server, when I take this one in the other room. Back in the system configuration, I'm in network services, network configuration, and I'm configuring the HMC2 port. It happens to be called ETH1. Most hardware devices on Linux and a lot of other operating systems, they'll start with 0. So ETH0, ETH1, and so on. And so it's a little confusing because on the back, obviously, that they're labeled HMC1 and 2. At any rate, this is HMC2. I've set it to 192.168.1.114, which is totally arbitrary. I'm just hoping that that is available. And I'm going to set it to a static IP for now. And we're going to continue and save that. And since I have this thing sitting here, remember I was telling a story about I tried to boot it up the first time and the fans weren't seated. Let's recreate that situation, and I'll show you what that's like and the type of error messages we get. So I'm going to pull all the fans, and then I'm going to tell the machine to boot up. So I'm in the power on menu. I'm going to say save settings and power on. I can hear the PSU fans revving up, and of course we're getting indicators on the real-time progress panel. And of course we can see the same progress codes coming out on the real panel. And what's going to happen is these early ones are going to be something to do with, I'm booting up, I'm doing this, I'm doing that. And eventually it's going to start spitting some out that's saying it's booting down, and we can go look at the error messages in the web UI. A few minutes later, and the very last progress code it spit out was 11007611. And we can look this up in the IBM documentation, and no surprise here, fan missing error. That's the last code it spit out. And then we can go look at the error logs on the ASMI, and of course we've got 4 of these fan unrecoverable errors, loss of redundancy, and the machine just won't start up because it knows it would fry itself. Pretty riveting, I know. Anyway, the cool part is these things do their best to not destroy themselves. Like, if you fired up a Pentium 4 machine with no fans in it, it would happily just burn itself to a crisp. But these enterprise machines are different. They run for hours and days. I shouldn't even say hours. They run for years at a time, and eventually you're going to have a fan wear out, or all of them in some sort of catastrophic event. I don't feel like doing it, but I suspect if we had it running and pulled all 4 fans while it was running, it would shut itself down pretty quick. Anyway, I'm going to get this all put back together and in the other room, and let's have a look at that HMC and that hub. Watch how fast it is to shut down Windows 7. Done. No bullshit. We've lost our way. Here is my HMC network infrastructure and the server itself. This is an eServer X-Series 336, but what's really important is the type, the model number. So back before you would run the HMC software, which again is just a Linux distribution with the HMC software running on it, you would run that in a VM these days. But back in the day, you'd run it on an actual physical machine like I do, and the software looks for allowed model numbers in the hardware somehow. And so only some of these machines have been graced by the IBM gods as being allowed to be HMCs. So I very specifically sought this one out on eBay. It's just running a Xeon processor or something. I think it has like 4 gigs of RAM, something like that. Pretty basic machine, but the type number is critical because it allows it to be an HMC. And this awesome looking thing is an IBM 8237 10 megabit Ethernet hub. This was sent in by a viewer and patron named Rainer all the way from Austria, I believe. And it does have a 1 megabit fiber expansion module. Maybe I'll use that someday. That'd be pretty cool. It's stackable, so you could get multiple of these and manage them together or something. I really like the look of this particular era of IBM networking gear. I think it's the 90s, at least mid 90s, late 90s, something like that. I know for sure they made token ring gear in this same sort of line. And when I started building out the HMC network months ago, I thought it'd be really cool to put this in permanent use. So now whenever I need to use the pSeries machines and the HMC, I have to power this on, which I love. So yeah, I'm putting this thing back into service, as it were, and 10 megabit is more than fast enough for the HMC to do all its interconnectivity. So pretty good use case, I think. I've got the POWER6 in there already. I'm gonna go stack this stuff on top of it. None of my pSeries gear or this has rails, so it's all just stacking on top of itself. So if I ever need to get to a machine in the middle, I have to pull everything off, and yeah, I'm just basically building a massive problem for myself. But it's hard to find the rails for these things, at least for a good deal. I've got everything back stacked in the rack and got a little carried away. I gave the hub its very own patch panel, even though I totally didn't need to. But I had all this stuff literally sitting on the floor in here, and it's really a shame we don't have the faceplate for him. That would look a lot cooler. So to make myself feel better, I got the hub racked up. Look at this thing reliving its glory days. All racked up. I actually broke down and bought the front bezel plate on eBay. It'll be here next week. In the meantime, here's a little Photoshop sneak peek I whipped up for you of what that's going to look like. So I've got the HMC and the 3 service processors for the HMC network coming through these cables right here. Now there's sort of an order of operations I've come up with over the years. You want to turn on the HMC first, make sure that it is totally healthy, and then you give power to the machines that are under management from the HMC. Now you don't have to turn them all the way on. We'll plug these 2 big guys in, but we won't turn them on. We won't need them. We'll only actually power on, as in boot, and power up this one fully with the loud fans and all that. And we'll get it under HMC control. So what I'm going to do is give power to this and my HMC. We'll make sure that comes online, and then we'll give everything else power to the service processors. And then finally, if we can get this thing under HMC management control, we'll power it up remotely. Okay, this one's plugged in. The hub is obviously plugged in. And this one's not powered on yet, so it's got this kind of service panel light diagnostics path, just like, well, not just like, this one's a little more sophisticated, but it's complaining. I only ever plug one PSU in, so everything complains that it doesn't have redundant power. So that's fine. This thing's pretty loud. You need a small little tool to press the power button here. There it goes. As you can see, we've got the HMC command center in here. This UI is from a KVM. On the other side of that wall, I've got a KVM that sends video, PS2, mouse, and keyboard all the way back to the HMC server. I find that that's the best way to interact with it, and so I'm going to use that here. And we can get this thing out of the way. And as you can see, it's just Linux. So it takes a long time to get through the boot process and even longer to start the software. So I'm going to let it do its thing, and I'll be back in a moment. After it boots into this Linux environment, this window isn't here, and I would say about 10 minutes goes by until you finally get to this where you can log on. I think it's a web application. Well, I know it's a web application just running in a browser window here. The default admin user is HSC root, and I have previously set a password for it. Now we wait longer. Here it comes. Okay, this is a hardware management console, and we can go into Systems, Servers, and if we click Servers, you can see it knows about 2 prior IPs. Those are the 2 P5s on the bottom. They don't have power yet. This thing looks like it's working just fine. So what I'm going to go do is plug in all 3 servers, the existing P5s and that POWER6, just their power supplies, and then we should be able to interact with them on this hardware management console UI. I've got all 3 servers plugged in. You can see the green lights on their operators panel are coming to life. And I can see link connectivity on the hub, which is great. Unfortunately, this hub is one of those like U1/2 size things. A U is like perfectly between the marks and the number on the rack, and this thing is a little off, so it kind of messes up all the spacing, but that's a problem for future me. I told you we'd talk about these cryptic symbols on the operator panel, and now's a perfect time because this panel is going to change a little bit once this thing is under HMC management, if we succeed. The only 2 things I can really explain to you are this one and this one. This one is the menu item you're on, so if I scroll, you can see 24021, and now we're back at the number 1 menu. So that's just what you're about to select, basically. This thing stands for the mode of the panel, normal or manual. I'm in normal mode, so you noticed I only have a few menu items I can get into here. You can change that to manual and start looking at things like the IP address of the HMC, control the machine a little bit. I can't remember from memory how to do that, but basically you get into one of these other menus and you can unlock this thing and put it in manual. You'll see later my other ones are in manual mode. This is the IPL speed. IPL stands for initial program load. I don't really know what this means. So there's like 4 or 5, maybe 4 valid values. V equals H is one of them. IPL is basically a fancy term for booting an operating system. So that's the boot speed. And then the T at the bottom, that's the IPL firmware mode. It can either be T or P. I also don't know what that means. Let me show you one of the other panels. Here's another panel, and the biggest difference, of course, is HMC equals 0. I think that's supposed to say HMC equals 1, as in it's managed by an HMC. It definitely is, as we'll see. But anyway, at any rate, when you're buying these on eBay and they power them up, if you see HMC stuff here, I'm not saying it's a deal breaker, but do your research. I've never taken one out of HMC management. I don't know how hard that is. I've read some stories online that it can be kind of difficult. So if you find yourself in the situation where you get to choose between 2 of these, it's better if it hasn't seen an HMC before, I think. Might not really matter though. And then you can just barely see that's an M for manual. So if I go through here, you can't really see, but I've got way more options because I'm in manual mode for my panel here. And then this one is in the same state as this one. I know that wasn't very useful because I'm not all that well versed in these things. I will say, while this one is totally functional, I definitely prefer this style. It just looks cooler and it's always visible. All right, back in here, away from all that noise, you can see why I like to remotely manage them from in here. That was noise canceled, by the way, in there, believe it or not. These are the server names that they had when I got them, and I just left them. And so before these were IPs, and now it knows they're here. And so we could actually select one of these. We could do tasks, operations, and we could power it on if we wanted, right? So let's go back to the main system management area. And down here we've got add managed system. I haven't done this in a while, but I recall it being relatively easy. So we're going to do it by IP address. I think I gave it 114. Hopefully I'm remembering that right. And you need to give it the flexible service processor password, which is admin in our case. Might make us reset that. Let's see if it can find it. So it says pending authentication. Presumably that means it found it. The nice thing about the HMC is you can click any of these things and a help menu comes up. And so pending authentication is just as it sounds. The managed system is waiting for the FSP password to be authenticated. I don't really remember how long this takes, so I'll be back. Okay, we've made some progress. It says pending authentication, but now it says password updates required. I was pretty sure that's what you had to do. So if we click into this machine, there's an option to update the password. I think it just makes you do this. Yeah, for posterity, I'm going to come back and watch this video when I forget this. The password is admin still. See if it lets us do that. And then back in servers, check this out. It knows it's got POWER6-1. That is exactly what I named that thing. It's powered off. Now, what we're going to do is see. Well, basically, this is totally under remote management now. I think it's exciting. So let's see if we can power that baby on. Normal power on mode. And more reference codes. So here in the HMC, it shows you the reference code that's actually live on the panel. And the reference codes are kind of nice in the HMC because you can click them, and what's it doing? It's doing an IPL. It's somewhere in its boot process, basically. Eventually, if that machine is still healthy after I moved it around, it will be powered on and we can do a remote terminal into AIX. So it's up and knows it's operating, but it's throwing all sorts of weird error codes. Oh, okay. This isn't weird. Waiting for user to select language on keyboard. That's what we were looking at earlier over the serial console. It was throwing up like a license, like a trial of a license had expired or something. That's why I don't really like going past these P5 machines. You start getting into like licensing headaches with IBM. It's on the open firmware menu, which makes sense. That's what I told it to do. That's that SMS menu. It knows that it's got 1 processing unit. It's got 2-ish gigs of RAM, and it's running AIX or Linux. Close enough. And here you can take a look at all the I/O and everything available. There's a RAID controller on board that thing, for example. Sorry, this is probably kind of boring. I like messing around in here. This capacity on demand thing, I have a trial of capacity on demand. View capacity settings. Yeah, well, whatever that means. So, finally, let's open a terminal window. Gotta accept a bunch of unknown certs. Open failed. The session is reserved for physical serial port. What? Let's do a terminal connection. I don't know the difference between a terminal window and a terminal connection. Well, this is probably a little in the weeds, but you made it this far, so you must be invested. I'm going to actually launch the ASMI UI that we were using earlier. I shut the machine down, actually. So here we are. You can actually get into that same thing from the HMC. And I'm going to, because I don't know how to do it in the HMC, I'm going to configure it to boot right to AIX. I think that's something we can do here. So let's see here. Oh, these might be those system boot speeds I was talking about on the front panel. Interesting. No, I can't actually tell it to go right to AIX. It says this option is only enabled when the system is not HMC managed. Okay, it's powered on anyway. In the back here we can see the HMC knows it's up to something. It is powering on. Doing a little research to see if I can get the virtual terminal on that POWER6 machine. And that port reserved for serial error that we got apparently is a thing. And that is because the machine has shipped from the factory in manufacturing default configuration, or MDC. IBM. Anyway, these are screenshots from a way newer version of HMC. I'm running 7, which is era appropriate for the machines in my rack. Yeah, there's that error, the exact error we were getting. Apparently you can poke around and change some things, so I'm going to try to fix that, and I'll save you the pain. I'll be back. Well, I think I tricked it into getting further. I really like messing with this stuff, and this POWER6 machine is doing stuff I've never seen the POWER5s do. Every time I make one of these videos, and I know it's a slog watching me interact with the HMC, I try to convey just how interesting and exciting they are. They're just so utterly bizarre. So let's see here. So this is the AIX partition. We're looking at the POWER6 machine, and if you just install AIX, on the one hard drive, behind the scenes, the architecture treats it as an LPAR, basically a VM. So the whole thing is like this massive hypervisor. It's very weird. Let's see here. Uh-oh, it powered off. I did not trick it into getting any further at all. Come on. I gave it another reboot, and maybe we've done it. It says it's up and operating. I saw a booting kernel earlier, or initializing or something. So here's the LPAR, our AIX instance, and it says it is running. So I think what we're going to do is try that console window again, terminal window. This should work this time. Accept our certificates as usual. Host mismatch, no problem. Come on. No, same problem. Oh, I'm going to be up all night messing with this. Oh, and the POWER6 operators panel, of course, has HMC equals 1 now. It's got the mark of the beast. And the other one started saying HMC equals 1 as well, instead of 0. I have no idea why it ever said 0. It's obviously under HMC management. I think you get the idea. The POWER6 machine is healthy. It's running AIX. If it had network access and I had SSH on that thing or whatever, or if it was actually hosting something useful like a web server or a database, I could of course interact with it. The machine is doing good. I'm building up quite a fleet of these power system machines. They're all under HMC management. And so I think the next step is to explore a little more, get them running actual software. I'd like to explore DB2, IBM's database offering that's been around forever. There's a free community version, probably some other versions I could find as well. And there is so much to explore with this power system stuff. I want to set up like a dedicated storage array that I could host multiple LPARs on. There's a bunch of like redundant power stuff. There's disk shelves I could buy. There's just like the sky's the limit now that I've got a pretty good HMC setup. And in fact, I could probably actually improve that network setup as well, incorporate it into the proper retro rack network a little better. Not sure where I'm going to take this. If you made it this far, I can't believe it. You might like this stuff as much as I do. I really like playing with these machines. When I kind of get the itch, this thing's been on that POWER6 machine with the lid off and everything. No front bezel, has been on the shelf over there. And I eye it every time I walk in here. And I've always been wondering, does it work? Does it work? And I finally powered it up a few days ago and I got hooked. I just like had to get it in the rack attached to the HMC see if I could get AAX running on it. Was already running on it, so that was easy. But yeah, I really like playing around with this stuff, and now I think it's time to actually like run some software on it and get some more sophisticated configurations going in future videos. I guess it's getting close enough. Next month, I'm going to be at VCF Midwest on Saturday, September 13th. So if you see me, definitely say hello, and if I still have them, I'll give you a sweet sticker. But I think that wraps it up for this one. You will be seeing this IBM stuff in the future. I can't stop thinking about it. But hopefully we'll do something exciting with it and get some software running and do something interesting. But until then, if you haven't already, please consider subscribing. It really helps the channel grow. And I've also got a Patreon. I post behind the scenes type updates, what I'm tinkering with, the occasional early video. I'm pretty bad at that, so I can't promise that, but it does happen. And currently my $5 and up patrons get access to the Serial Port Discord. That's a shared Discord between myself and the Serial Port channel. It is a great group of people in there. I spend the vast majority of my Discord hours in there. Hopefully I see you there. But until the next video, thanks a lot for watching.